It now. Last class, we would have looked at wave phenomena. Could anybody remind me of one wave phenomena? One wave phenomena. Anybody? We looked at a couple. A wave phenomena. Don't be so quiet and think, Vani. Could you give me an example of a wave phenomena? A wave phenomena.
Reflection.
Okay. All right. Was another one? Was another one, Zachary? A wave phenomena.
Refraction.
All right. And you know what? That's the main one we're going to be looking at today, you know. That is the main
Mm.
one we're going to be looking at today. Wait, take a second. Yeah. So the main one we're going to look at today is refraction. While we're on the topic of wave phenomena, could anybody give me one other example? Adil, could you give me another example of a wave phenomena? Do you remember the wave phenomena? The different things that could happen to a wave?
Nasu.
All right, so Adil, think of what could happen to a wave. Think of what could happen to a light wave. A light wave. A light wave could be reflected. What else could happen to it? Tell me, Adil. What else could happen to a light wave? It could be reflected. What else could happen to it? Okay, let me go back. You will have to remember these wave phenomenons. Otherwise, you're cooked. I don't want you to be cooked. And like I noticed that we learning real stuff in class, but after all, let's take a week off, everything just like vanishing. You can't have that. So if you want to do good in physics, you have to like be practicing, right? So, Adil, these are the different types of wave phenomena. You have reflection, refraction, diffraction, interference, and dispersion. So, quickly, Adil, which one is this? Which one does this look like? Do you know what that looks like?
Fraction.
What does it look like?
Diffraction.
That's diffraction, right? Diffraction is when a wave goes through a very narrow slit and the wave starts to spread out after it exits the slit. Now, the size of the slit needs to be smaller than the wavelength for you to notice a diffraction effect. All right? Could anybody tell me what this looks like? Adil, you know?
Infraction.
Where is it?
Infraction.
Infraction? We see an infraction.
Oh,
Infraction? Nah, nah, nah. Here what? Let me think about this thing logically, Adil. Imagine if this normal line is a mirror, and this is where you're putting into the mirror. Like imagine this is you standing over here. What you noticing?
reflection.
Yeah, you see enough for yourself. That's a reflection. No fancy way or anything. That's just simply a reflection. Okay. Could somebody other than Adil tell me what this is? How about Drew? Drew, could you tell me what wave phenomena this is? Say that
Which
again?
one? The cup?
Yeah, the cup and the straw.
Um, Refraction.
Excellent. So refraction is when you have light rays going from one medium to what? So vary like over here. The
But change in medium.
exactly over here it goes from air to water. Would light travel the same speed in different mediums?
No,
Nah. So like the density medium, you think it could travel faster or slower?
slower.
Exactly. So it'll bend more. What is this? Shina, what type of wave phenomena is this? And Vani, you could help her, all right? But Shina, what kind of wave phenomena is this? Starts with D. Can I hear in Shina? Vani, do you remember what type of wave phenomena this is?
Dispersion?
Right, because it looks like the white light ray gets dispersed into its constituent colors. Did you ever know that? Vani, did you ever know that if you mix all the colors in the light spectrum, it actually get white? Did you know that?
No.
No, like okay. This might be mind blowing, right? But you have a TV, you have like a flat screen TV or something in your living room.
Yeah.
I want you to do this for me, right? I want you to look up a white background, and I want you to take your eye and I want you to place it really close to the display. When you look close, you'll actually see red, green, and blue pixels. You won't see white when you look up close. That's really weird, right, Vani? When you think about it, that's really weird
Yeah.
because you would think red, okay, red, RGB, red, green, and blue. How that creates in white? And that's so weird. That's sounding real weird, right? Red, green, and blue creating white. Yeah.
I
But
could try it.
do that for me. Um, and let me see if I can show you a little example quickly now. See if I can show you a little example. Did anybody else know that? That if you combine red light, green light, and blue light, it'll create white. Did anybody know that here? Shayna, Adele, Zachary, Drew, Vani, Danelle.
Yeah.
Okay. You see, they don't show you this, you know. I mean, Vani, would you say that's common sense or not? That's, would you say that is common sense? Oh,
I don't know. Maybe.
I
Yeah.
I wouldn't say it's common sense. It wouldn't be common to me. I feel like you say that because I asked you and it was like scared to say no, but I wouldn't say that is common sense. I mean, how you supposed to know red, green, and blue to create white?
I don't even know. And art is like a whole set of thing, you just know it somehow, I guess.
Well, you see, the thing is, right? It's very different. In art, you have paint being applied to paper. That is what you call additive interference. And well, light. Wait, let me just make sure I remember it, right? Give me a second. Is paint constructive interference? Even I just forget things sometimes. All right. Okay. So, Vani, the proper way to say it, right, is that light is additive. That's what light is. But when you have colors on paper, that is actually subtractive. So let me show you what I mean by this. Check this out. Because Vani, on a piece of paper, right? On a piece of paper, if you put red, green, and blue, you think you're gonna make white, you think you're gonna make like a dark color.
It will make a dark color.
Exactly, but saying light gonna make white. I know it's sounding a bit confusing.
Yeah.
All right, I have a perfect picture to show you. Okay. All right. So, Vani, look at this for yourself. So this is a wide screen, right? But when you look at it closely, what are you seeing? What are you seeing?
Blue and red and some green.
Exactly. But if you look at it from afar, yeah, you really have to look at it from afar, right? You really have to look at it from afar. But when you do, you'll realize that it looking like white. But when you go up close to it, it's really not white. You see it now for yourself, right?
Yeah.
Like when you look at this, you see in white? Be honest with me. You see in white?
No.
Okay, but like what about now?
It appeared. White just appeared.
That's so cool, right? That's so cool. I know. Physics is really cool. Okay, cool. Now the phenomenon we're going to look at today is refraction. Now I would have spoke about refraction at the start of class. Vani, could you remind me what refraction is? Refraction
Where
is what?
the waves bend or change
It's the
when they enter
bending.
one
It
medium.
it is the bending of the bending. Is bending off.
Yeah.
Say that again.
Waves
Right, it's dependent of waves.
when they enter another medium.
Right. So we need to look at the laws of refraction. They love to bring the laws of refraction. They love to. So let's look at laws of refraction. So I'm going to put down the laws, and then we're going to look at an example, a diagrammatic example, so we can see how everything is actually behave. Number one, the normal is perpendicular to the boundary line. I find this like writing real thick today, boy. It's weird. All right, yeah. So the normal. Also, I don't like this quietness. Somebody say something. It make my brain hurt. Zachary, say something. Like, did you know that white light is just composed of red, green, and blue light?
Mm, yeah, kind of. Yeah. What I do is just like when you combine all the colors of the spectrum, it just get you white.
Okay, okay. And okay, I have a question. You have like you're washing a car or something, and like a bit of mist. You have a bunch of mist in the air. When the light hit the mist, you just see different colors, and
Yes, sir.
yeah, that's refraction. So this is the first law of refraction. Zachary, could you give that a read for me?
The normal is always perpendicular to the boundary line.
You're probably confused about that. Okay, who here is confused about number one? Keep in mind, I never showed you the diagram yet, eh? If you're confused, talk to me. I never showed you
Yes,
the diagram.
I confuse it.
I like that. I don't like the fact they're confused, but it's good that you're honest. Right, Vani? You ever hear about that before? The normal is always perpendicular to the boundary line?
No, this is
No?
the first time I hear that.
Okay. And the other law of refraction says that light waves bend when they pass through. I have a question, right? Like when are they in class, are they just feel scared to unmute and talk or something? Like I'm curious. Like I want to get like I want to do like a little study. So like Vani, when you're in class, you feel comfortable to talk.
No, it's normal.
It's be normal.
Yeah.
Okay, okay. The vibe that I was trying to like invoke in class is like, you're talking to like a friend. Like obviously you don't want to be disrespectful, but like, imagine like you're on the phone with a friend or like a Zoom call and like we just hashing it out and like trying to understand this. I don't want it to feel like inferior or anything, right? It's a safe space. So I don't like the silence. The silence has messed with my brain. Right. How's your result? All right, so Zachary tried to finish his sentence. So I want you to read what I've wrote so far and see if you could figure out anything. See if you could figure out anything. So Zachary, get a read from her. Number two,
Light waves bend when they pass through a different medium as a result of light
as a result of light, what? What did I say about light?
reflection.
Nah, nah, nah. What did I say about light? Think about light traveling in air versus water. What would happen when it goes from air to water? What's gonna happen?
The waves will bend because it's in a different medium.
Okay, okay. It come like you're saying what will happen, but you're explaining it by seeing what will happen. But you're not really giving me a reason. Okay, think about it like this. Where do you run faster? In air or water?
Yeah,
Okay, so imagine you're running at the same speed and you enter water. Are you going to keep moving in the same direction or will you deviate slightly? Think about it. Like you're on the shore, right? And you just
yeah.
run into the water. You just run into the water at the same speed. What's gonna happen when you run into the water at the same speed?
I would slow down.
You go slow down. And when you slow down, you think you're gonna keep in the same direction or the waves might push you in another direction or something.
You really might push me in another direction.
Exactly. So let's look at a couple factors there. When you're going from air to water, what happening to your speed?
It is slow.
It
Slow
is slow
down.
down, right? And the more dense the medium is, and the slower you'd move,
Mm-hmm.
and the more you would bend. So what I really wanted to hear as a result of light, what? Based on our talk just now, see if you can figure it out. What's the main
Is it
factor there? What is changing?
the speed of the light?
Exactly, as a result of light traveling at different speeds.
Oh, I'd say that makes sense.
Yeah. Because that's the only thing that really changing, you know. And what do we call this relationship? Well, this relationship is known as Snell's law. Is It's called Snell's law. Have any of you guys heard about Snell's law before?
Nah, so,
Nah, okay. It kind of sound like snail length.
yeah.
Right, so let me show you what Snell's law actually says. So you have Ni sine I. Don't get scared. I promise it's not that deep. I promise. Ni sine I is equal to Nr sine R. Okay, who here is scared? Vanny, you see what you see silencing boy. Tell me if you get scared.
Yeah, I guess scared.
I know that Adele, you get scared. You see silent, you see me talking about big fancy words and things. Let me know if you get scared.
Oh, yeah.
Shayna, what about you? You feeling cooked?
Partially.
Partially. You do this before?
No.
You know, okay. Jada, I see Jada joined. Danelle, Ambika, I'm not giving you a chance. Right, Karina. Karina, good morning.
I say,
Karina, you was a little late. A little late. Yeah, boy.
I'm not feeling good.
I feel like this is the hospital, boy. Karina not feeling good. Shayna not feeling good. Amika not feeling good. Hey, boy. But I'm sorry to hear that. I think you had told me he wasn't feeling well in the last couple of classes, so I hope you get better soon. Okay, so Drew, I'd like you to read number two for me. Read back number two for me and make sure you understand it to some extent.
Light waves bend when they pass through different mediums as a result of light traveling at different speeds. This relationship is called Snell's law.
Okay, in your opinion, Drew, do you understand that light will travel at a different speed if it goes from one thing to another thing? Makes sense, right?
Yeah.
Okay. So what does Ni stand for? Ni stands for the refractive index for the incident ray. Refractive index. Okay, I know right about now you're feeling mad cooked. I know. Right? I stands for the angle of incidence. Right. Okay, I have a question. So, Vani, if I is the angle of incidence, and what phenomena are we dealing with here, Vani? What's the name of this phenomena? Remind me. What's the name of this phenomena?
Refraction.
Okay, so we're saying that the incident ray. Okay, you could be the incident ray. Imagine use the incident ray, right? Or like let me give you an example of the incident ray. You see this straw over here? Okay, okay. You see this straw over here, right? You see the straw? Wouldn't that straw reflect light and you'd be able to see it?
Yes.
Okay. So like you see how over here it's in air, right? You could see it's in air over there. We see it now.
Yes.
And over here it is in water. Don't you notice that there's like a phase, like a shift? You see any shift, right?
Yeah.
Well, we need to measure that somehow. We need to measure that somehow. So over here, it is entering the boundary. So you'd call that the incident ray. The incident ray is the incoming ray before it goes into the other medium. Now, Vani, would I say that this is the normal ray, or would you say that that is ray after refraction? Or would you say?
After refraction.
Right. So if this is the angular incidence, and you know this is refraction, try to come up with a word, a phrase for it. That would be the angle. That'll be the what? So this is the incident
Angle of
ray.
refraction.
Wait, this is the incident ray. This will be the what?
Angle of refraction.
No, it wouldn't be angular refraction. It'll be refracted ray. Refracted ray. You'll see
Ah,
what
okay.
you'll see what the angle of refraction is just now. Right? Refractive index of refracted ray. All right. Shina, if I is the angle of incidence, what do you think R is? Shina?
Angle of refraction.
Right, angular refraction. And that would happen when it goes from A to the different medium, right? Because Shina, wouldn't it be helpful if we knew how much it deviated by, like the angle?
Yes, sir.
Hmm. Angular refraction. So I'll give you all the chance to copy down your notes just now. Please note that this formula over here, it works every single time and for every single medium. So I'll just write over here that this is the general formula for Snell's law, general formula, and I'll show you guys the formula that you might typically use in class. So this is the general formula. And this works for any two mediums. Now you're probably wondering, sir, I hear you mention this refractive index thing. What is that about? Who here don't know what refractive index is? It's fine, I don't expect you to know it, but just be honest, man, tell me. Who here doesn't know what refractive index means? Drew, you know what refractive index means? Can I hear Andrew? Zachary, do you know what refractive index is?
Nah, sir.
Okay, it kind of sounds like we're measuring something, right? Like refractive index. It kind of sounds like we're going to reference something. So, like, let me think. And when you go from one medium to another medium, light would bend because of these difference in speed. We know that, right?
Yes, sir.
And depending on the density of the medium it's going into, it would either bend more or bend less. We agree?
Yes, sir.
Okay. Now, on it, what where does light travel? What does light travel through? 90% of the time.
Yeah.
Air. So you know what we decided, Zachary? We decided that air would be the standard. It'd be the standard refractive index. And well, if it's in air, then we treat it as normal. So what do I mean by that? I mean that if you're talking about the refractive index for air, it is actually 1. Because we say that, okay, Zachary, think about it. If you multiply something by 1, what will you get? Like say I multiplied 5 by 1, what will I get?
5.
Exactly. And if light passing through air, you would say that the think about it, Zachary. Isn't air like what light travels through? So I mean, isn't that how we perceive light? We perceive light because it passes through air.
Yes.
So, so we could only so we would have to compare how it going in air to some other medium. So air is the standard. Air is just one because we are assuming that air is where the light waves not refracted. It's just there. It's just existing. It's just there to be observed. So Ni sin I is equal to Nr sin R is the general formula. Now this works for any two mediums, but there's a specific application of that formula, and this is the specific application I'm talking about. So you would learn that I'm trying to remember this right. So I believe it's N is equal to sine I all over sine R. I believe this is it. Let me just check briefly. I'm doing all of these notes from my head, eh? I'm doing all of this from my head. I can quickly derive it. Give me a second. So like Ni sine I is equal to Nr sine R. And you go the angular incidence is A. So that would just be 1 sine I equal to Nr sine R. You want to make Nr the subject of the formula, so Nr is just going to be sine I over sine R. Yeah, that's correct. Zachary, you see how I could derive anything like if I forget? You see how you can
Yeah.
see how I could do that? I want Olet to be able to do that. Because I don't want Olet to be freezing up in the exam. Think about it, Zachary. I just told you that if light is in air, what is the refractive index? If it is in air, what's the refractive index if it's in air?
1.
Okay, so is he Ni? That just means the refractive index of the incident ray. Incident ray is where the light wave is coming from. If it's coming from air, then it's not going to be refracted. So I replaced Ni with 1. What is 1 by sine I? What is 1 by sine I?
Right.
Exactly. And then we have Nr sine R. I would not know the refractive index of the refracted ray. I would not know that. I would not know that. All right. So I'm going to leave it blank, and then I'm going to make Nr the subject of the formula. To make Nr the subject of the formula, I'll divide both sides by sine R so that it will cancel off to leave me with just sine R. So this is a formula you'll be seeing a lot in school. You'll be seeing N is equal to sine I over sine R. That's what you'll be seeing.
Yes. So hold on, I'm a mother calling me to do something quick.
Okay, no problem. Right. Yeah. So, Vani, you're probably real confused right now. Like, wow. Vani, do you
Yeah.
understand that if we are in air, isn't that what we see light as all the time? Don't we see light passing through air? Think about it.
Yes.
So if we see light passing through air our whole lives, wouldn't we put that as like the reference point? Because we see light in air. So like if you have light in air, would you call that refracted? Or would you just say it's like normal light in air?
It's normal.
It's just normal, right? So would it bend? Would light bend in air for us?
No.
No, maybe if we lived underwater, then it would be a different story. And we would have to use the refractive index of water. But simply put, we live on land. So this is the reference. So if light is in air, the refractive index is 1. That's what I'm trying to say. Now, Vani, in CSEC physics, most of the time you'll be going from air to some other medium, typically. So then we will have to use a specific application of this formula. So let me show you what I mean by that. So Vani, this is Snell's law, by the way. That formula is Snell's law. And let's try to figure out something here. So Vani, if we know we're going from air, so let's just say we're going from air to some other medium. Air to some other medium. Then we know that air, what's the refractive index of air? Remind me. What's the refractive index of air?
And I,
Nah, check it out over here. And I realize I
oh,
write this kind of bad. Okay, let me just fix this. Refractive index of medium, right? So, okay, I think I need to draw the diagram for everybody to understand and clear up this confusion. So I'll do that. When I say Ni, I'm talking about the refractive index of the medium that the incident ray is in. That's what I mean. And when I say refractive index of refracted ray, what I really mean is the refractive index of the medium in which the refracted ray is in. So here what Vanny, we'll draw a diagram and we'll try to clear up the confusion. Forget about all of this. Let's just look at a simple diagram so you can kind of get to see what's happening. So I'm going to draw two lines over here. Let's just say that over here, we want to call over here air or water.
air,
Okay, let's just call this region over here air. And we want to call this region over here.
water,
Sure, no problem. Now, if this region here is air, I hope everybody paying attention, eh? I really hope everybody is paying attention to this. So, Vani, over here is air, and over here is water. That would mean that this line is doing what? What is that line doing? Tell me, Vani.
separating them.
It's separating them. So, we call that the boundary line. You with me?
Yes.
This is called the boundary line. And this is a line that separates the two mediums. I think we could see that. It's separating the air from the water. Now, this other line here is called the normal. This is called the normal. And when you're drawing the normal is typically drawn like dashed. So it'll look like this. Now, Vani, I want you to tell me, what angle do you notice between the boundary line and this dashed line I just drew? What angle do you notice? What angle is that? So I have a dashed line over here, and I have a right angle, right? You seeing that?
Yeah.
Okay. So we would call this dashed line the normal. This is the normal I was talking about. So earlier, when I told you for the laws of refraction, what did I say about the normal? It'll make sense now. What did I say about the first law?
It's perpendicular to the boundary line.
Okay, does it make sense now?
Yes.
This is what happened, you know. So the boundary line just separates the two mediums, and the normal is always 90 degrees to the boundary line. Now, Vani, you're probably saying why we need a normal? We need a normal to keep track of how much the ray is bending by. Let me show you what I mean by that. So let's just say you have a light wave incoming from the air, right? Can we both see that? So like you have, let me just say you have the straw, right? Within the straw, have a light wave, so you can see that the it entering. So this is the incident ray, it incoming. I'm going to represent it by an arrow going in. You see that?
Yes.
Okay, so we see in the incident ray. Now the angle that we are going to measure is going to be with reference to the what? Again, Fanny, think, why would I put the normal over there? Why I put the normal over there? Wouldn't I need to keep track of the angle somehow?
Yes.
Yeah, and you're probably a little confused, but think about it. Vani, in this topic, I saying that light gonna bend, right? And if okay, if I telling you light gonna bend, and you might ask me, well, you have any proof? You have any numbers to back that up? So if I'm saying that light is bending, wouldn't I need to compare the angles to see if it actually bending?
Yes.
Okay, so I'm putting the normal line down there to actually measure the angles. So we have the air, this is called the incident ray, and we have the normal over here. Could I use the normal to measure angle over there? Yes or no?
Yes.
Yes, I could. Now, what do you think we'll call that angle? So again, this is the incident ray. This is the incident ray. because it's coming in. So the incident ray is a ray that comes in and it goes from it it's what was there in the first medium. So the incident ray is incoming. And where do you think the incident ray is gonna go to? According to the diagram, where do you think it's gonna go to?
To the refracted ray,
Right? When it enters what? When it enters what?
water, or a
Excellent.
next medium.
Excellent. So we drew the incident ray, and what angle do you think I'm gonna call this? So check it out. We had look at the things we had. We had refractive index of the medium, we had angle of incidence, we had refractive index of medium, we had angle of refraction. So if you had to say, what do you think this pink angle would be called?
I don't know.
You could do this, you could do this. I want you to use your brain and figure it out, because you'll remember it that way. So Vani, we said that this ray was the what? Was the what ray?
Incident ray.
Right. So what do you think that'll be? Look at all the options it could be, and you figure it out.
Sine?
No. So these are the four things it could be. Well, we already using well, give you the answer there. We already using we're already using the incident ray. We're already using that. Think about it. We already have incident. This is the incident ray. What are we measuring here? What are we measuring there?
The angle of incidence.
That's all the angular incidence. So that'll be I.
I was a bit confused because I thinking like it have like a specific other name for it.
No,
Like,
no,
I
no,
have theta and
no,
stuff.
no. It's real simple. So I is the angular incidence. Now, there's some rules you need to know when it comes to the light waves bending. So I'll just put down the rules over here, right? If it is a denser medium you're going to, what would be denser? Water or air? I'm just curious. Tell me.
Water. Water.
Yeah, water. So check this out. If you're going to a denser medium, then this is going to happen. Your refracted ray is going to bend towards the normal. Refracted ray is going to bend. Okay, and Fanny, if it going in a denser medium, and I saying it gonna bend towards the normal, we think gonna happen if it's a less dense medium. Take a wild guess.
It bend.
Okay, then okay, think about it. Denser medium and less dense medium. They kind of sound like opposites, right? Like okay, denser and less dense. And that's someone kind of opposite.
Yes.
So where's the opposite of this? So read that for me.
The refracted ray is going to bend towards normal.
Okay, what's the opposite of that? What is the opposite of that?
The refracted ray won't bend towards normal.
Okay, so where's the opposite of bending towards? What's the opposite of the word towards? Anybody could answer this, by the way. Anybody could answer. What's the opposite of the word towards?
Away.
Yeah, away. So if it's going to a less dense medium, then we are going to say, well, we're going to observe that the refracted ray is going to bend away from the normal. Okay, so you need to know that. This is like secret knowledge here. You need to know this. If you forget this, you might be cooked. So Again, after we're done with the explanations and I make sure everybody understands what's happening, because I feel like everybody's lost right now, other than Vani and Shina. I feel like you all were following along. Shina, you understand everything happening so far?
Yes, sir.
Okay. So I'll explain it when we're done. But Vani, in our instance, we're going from air to what? In this simple example, we're going from what here? What to what?
Air to water.
Air to water. And which condition would that be over there? Denser medium or less dense medium?
Less dense.
Nah. You sure? With water. Water is what? Water is less dense or more dense?
More dense.
Exactly. So my refracted ray, this is going to be my refracted ray, right? I need to figure out where to put it. Now, you help me. We're going to our what? We're going to water, which is our what? Water is our what?
A liquid.
Right. It's a denser medium or less dense medium compared to water. I'm asking obvious questions here. Don't get confused. Like don't think I'm trying to trick you. I'll keep asking you the same questions over and over and over to reiterate the point. So Vani, which one is denser, air or water? Again, not a trick question. Which one is denser? Okay, and here and Vani, somebody else want to tell me what is denser, air or water?
Water.
What?
Water.
Water. Now, according to the table I just drew over there, if we're going to a denser medium, what happens to the refracted ray, which is a green ray over here?
It will bend towards the normal.
Okay, so tell me which one you think would be correct. Okay, right now, is it looking correct?
No, sir.
Water.
No. The way it is right now, it would mean that the incident ray was never affected. Think about look at it, guys, and if you're confused, look at it, right? What I have over here, aren't I seeing that the light wave would just move as normal? Isn't that what I drew over here? Look,
Yes, sir.
but okay, if you're going from air to water, will the light waves be going in the same direction at the same speed?
No, sir.
No. So this is very wrong. Okay. Option two now. Does this look correct?
No, sir.
How about the rest of you all? Could somebody tell me what I just drew over there? I just drew the refracted ray bending closer to the what? Somebody tell me. I just drew the refracted ray. Say that again?
Closer to the boundary.
Exactly, but that's wrong. If it's going to a denser medium, the refracted ray is supposed to bend towards the.
Normal.
Normal.
This is the correct thing. Yeah. Funny. You understand what happened or no? Uh, I see in Vanny. Vanny was going real good. All right. Everybody else understand that?
Yes, sir.
Yes, sir.
Okay, and if you are confused, don't worry. I'll go it over several times just to make sure you understand. But for those that do understand, that's great. Now you should be able to understand what I mean by angular incidence and angle of refraction. So you see this green line over here? If the pink line was called incident ray, what do you think I'm going to call the green line? Somebody take a guess. Anybody in class? If the pink line is the incident ray, what do you think I'm going to call the green line?
Refraction.
Nah, I'm not going to call it refraction. I'm going to call it the
Refracted
refracted.
ray.
I'm going to call it the refracted ray. Cool. And this R, what does that R stand for?
The angular refraction.
Refraction.
Perfect, guys. Excellent. Excellent job. Now, what was Sir saying? I was saying that this formula over here is a general formula. And you could actually use this formula for any two mediums. But in CSEC physics, you will most likely be going from air to some other medium. That is typically the standard. But don't worry, guys. I'll show you all both cases because CXC is kind of sneaky and maybe one time you'll need to know this formula. Zachary, I feel like you would hate because in school, I'm sure you're not going to learn this formula. I know. I'm sure you're not going to learn this formula. I'm very sure. Your teacher just going to tell you n is e they're just going to tell you n is equal to sine I over sine r. But what people don't understand is that that formula only works if you're going from air to something else. But Zachary, and she could be going from like glass. And she could be going from like glass to water, if that makes sense. Like think about it.
Yes,
Uh
sir.
like if I have a glass and I put water in the glass, think about that for the moment. Think about that for a moment. The light waves are gonna enter the glass. And then from the glass, where's it gonna go to?
The water.
Exactly. So you need to know how to handle you need to be able to handle more than just air to something. So this formula is very important for that. Cool. Let me show you all the other formula. And this is where it's going from air to another medium. This is the formula you're going to use. NR is equal to sine I all over sine R. Let's explain everything, please. So what does NR mean? This is a refractive index. Okay, so guys, if I am saying that this formula is strictly for air to another medium, which refractive index would I know then? Zachary, if I'm saying refractive index, right? Refractive index. Refractive index of what? See if you could figure that out. Again, this formula literally tells us air to medium. Which refractive index would I know for already, Zachary? Which one would I know?
Yeah.
I would know air, right? What's the refractive index of air?
1.
Right? We know that the refractive index of air is just simply 1.
Mhm.
So then, if I know that, the only thing I wouldn't know is the refractive index of the
Medium.
exactly refractive index of medium. I don't know what that is. I do not know what that is. Cool. I would just stand for the angular what? What does I stand for? Do we know? Why not?
Angular incidence.
Right, that's the angle of incidence. And the angle of incidence is measured with respect to the what line? What line did we measure it with respect to in the diagram?
Normal.
Exactly, we measured it with respect to the normal angle of incidence. This is one of the harder topics in CSEC physics that a lot of people just never understand for the life of them. They just never understand this topic. And what do you think R is going to be called?
Refraction.
Yeah, angular refraction. Boy, Vanny was going real good, boy. Chew Wi-Fi going. That's real sad. Adil, I didn't hear from you in a long time. So when we're going over this from scratch, yeah, I'm gonna call you. Right, Adil? I'm gonna call you. I'm gonna call Drew. I'm gonna call Karina. I'm gonna call Danelle. So angle of refraction. Let me just fix up the notes so you all could take down the notes. I'm trying to make these notes as complete as possible. So when you're looking back at these, you're not confused by anything. Danelle, how do we perceive light? Think about it, Danelle. Where do we live? We live in the sea, space, or air? On land? Tell me, Danelle. Where do we live? Oh, Danelle?
So
Can
I
you?
can't continue to answer questions right now. I'm
Yeah.
driving and I head into class.
Oh, okay, okay. I understand. All right, Adil, where do we live? Do we live in land or sea? Where do we live?
Land.
We live on land, so and it would make sense for us to compare light on air to everything else.
Yeah.
Yeah. Specific case, and this is where you're going from air to another medium. So Shina, in this formula, what is always supposed to be the incident? The Tell me, Shina, in this example, what is always going to be the incident ray?
One.
The incident ray is always going to be where? In what medium?
Yeah.
Exactly. That's the thing about this formula. You could only ever use this formula when you're going from air to another medium. That is a use case for that formula. And I will show you why in the proof. Look at the proof. So these are the formulas you need to remember. Have these locked in. So Shana, I want you to help me with the derivation quickly. It's nothing complicated, I would say. Just a quick derivation. So Shana, do you remember the general formula for Snell's law? General formula?
Yes.
Okay. So we're gonna start off with that. What is the general formula for Snell's law?
N I sine by R equals sine R. NR sine R.
Okay. And in this example, I'm saying that we always go from where to where? We're always
It's
going. Okay. So Zachary, you go stay with me too, right? Karina, Adil, everybody stay with me. So this is the general formula for Snell's law. And in this specific instance, I'm saying we're going from air every single time we're going from air to something else, to some other medium. So guys, if this is the case, right, then where would the incident ray always be in? Let me repeat that one more time in case I confuse somebody. Remember, incident ray is where the light is coming from. So if I am saying that we are always going to be in air and then we're going to move to another medium, where is my incident ray going to be in? Is it going to be in water? Is it going to be in air?
Maybe the air, so
yeah.
It's always going to be in air. And that is very important in your understanding of this topic, or this specific formula at least. So, uh, right. Yeah. So, Shina, we're saying that you're always going to be in air, right? So this is where the what I'm saying, this is where the incident ray is going to live. The incident ray is going to live here.
Yes, sir.
And if the incident ray is going to live here, then automatically, what would Ni always be equal to?
One.
And okay, if anybody is confused by that, could somebody other than Zachary and Shayna tell me what the refractive index for air is? Somebody other than Zachary and Shayna, what is the refractive index for air? The refractive index for air. Adil, do you know what the refractive index for air is?
It
Yeah.
would be one.
Wait, Adil, you know?
See, I ain't hear what you say.
The refractive index for air. For
Yeah.
air. Do you know?
Not sure.
All right. So Adil, the refractive index, it tells us how it kind of gives us some measure as to how by the degree the light is gonna bend by. Now, Adil, let me repeat that one more time. The refractive index tells us by what factor the light ray could bend by. Think of it like that. So Adil, if light is in air, will it bend?
Yes.
No. I mean, we just see light in air. Like, think about it. We live on land. Adil, we live on land. How do we perceive light? We perceive light through what?
Yeah.
Air. So if we perceive light through air, then we would set that as the standard. So the angle, so the refractive index for air is what? Think about it.
One.
It's just one because it doesn't. If if we are using air as the reference, then I would say that the refractive index is one because it's not changing anything. And if you multiply anything by one, to get back to the original thing. So the refractive index here is always going to be one. Do you follow with that?
Yes, sir.
All right. And Adil, if we know for sure that the refractive index for air is always going to be one, what could I replace here in this equation?
And I
I could replace Ni with what?
one.
Perfect. So we're gonna end up with 1 by sine I is equal to NR sine R. And we are trying to figure out an equation to find the refractive index. That is what we are trying to figure out. We are trying to figure out an equation to find the refractive index of the other medium. That's what we want to figure out. So we want to find the refractive index of the other medium. So can anybody identify which variable there is going to be the refractive index of the other medium? Could anybody identify that? Which one would that be? Anybody? Guys. So which variable here?
NR.
How much of you all agree that NR would be the refractive index for the other medium?
Yes, I agree with that.
You all will be correct, right? So how would I make NR the subject of the formula then?
Divide both
You
sides.
divide by sine R.
Correct. I would divide both sides by sine R. Now, what is 1 by sine I? What is 1 by sine I?
Sine I.
Right, so we are just going to end up with sine I all over sine I all over what?
Sine R.
And that is going to be equal to,
NR.
for anybody that's confused, the sine R and the sine R is going to cancel off there, right? So that's just going to leave us with NR. Did we prove the formula that I said you would learn in school?
Yes.
Yes.
Yeah, we prove it, right? Now, I really hope your teacher would show you all the general formula, which is Ni sin I is equal to Nr sin R. But I am doubtful. But, in C-Sec physics, if you have to go from a medium that is not A, at least you know what to do. You'll have to use this formula. And you will need to know what the refractive index of the first medium is and the refractive index of the second medium is. Okay, cool. And these are formulas to know. Don't worry, guys. I will review everything. Give me a little moment. I understand that some things here could still be looking confusing. It's fine. I feel like there's a lot of things crammed into one page. So like maybe okay, how will they find this is like will they find like the notes too cramped or like will they want me to move around some stuff? Let me know.
No, so I find it good.
That's it.
Okay. I have to there's another formula for what's it? There's another law you need to know for refraction, eh? So let me just write down that law as well and I'll give all it to copy it down. Now this one will confuse you all again. I mean this topic is one of the more confusing topics for sure. But we'll figure it out. So this is the third law of refraction that I forgot to write because I always forget it. The angle of incidence, and the angular refraction um and if you when I write this you're gonna be confused at first. And nobody will take the time to explain this. I promise. Like in school, the teacher will just write this down and I promise. Like I bet. I could bet. So the angle of incidence and the angle of refraction lie on opposite sides of the normal. Yeah, we need more space, guys. Definitely. Well, they hearing the neighbor next door talking about punching and thing, boy. Hey, boy. Are they hearing that?
No, but I think that
Nah, so
conversation.
That's good. That's good. I'm happy you're hearing that. Good boy. Now we're talking about punching, yes. Man says he licks our life. It's not. It's not. Man says he licks our life. I might be a bit biased there. Right, lie on opposite sides of the normal. Right, of the normal. But all lie on the same plane. Cool. Um, I know you all are going to be confused by this third one. I know. I'm saying so because when I was doing physics in secondary school, I never understood it. It's only when I started teaching I understood it. Because you need to like actually see it to understand it. So like, shit, now wait, read three for me. This is the third law of refraction. Read that for me.
The angle of incidence and angle of refraction lie on opposite sides of the normal, but all lie in the same plane.
Do you understand what I mean?
So yes, kind of, yeah.
Kinda. Okay. Zachary, what about you?
I understand the first part, the it lie on opposite sides of the normal, but I don't understand the same plane part.
Aha, you see, that is the part. That is the part that nobody does explain. Check this out, eh? I'm going to try my best to do a drawing here. Now, if I ever look at my solutions video for physics, I had explained this in it. I think it was 2024 or something. Check this out. So, Zachary, forgive my drawing. I'm trying that thing here. So, like, so what exactly is a plane? You can think of a plane as a 2D surface. That's what a plane is. So you see how I drew like a flat surface over here? You seeing that?
Yeah.
That is what you call our plane. Maybe it might help if I shade it. Give me a moment. Okay, so Zachary, you see that? That's our plane. A plane is just simply a 2D surface. Understand? Tell me if you
Yes,
do
sir.
that. Alright, so this is the plane. It's all going to hit you like a truck. Okay, I really try my best to do a drawing here. Uh, that would look like. Hmm. Okay, all you really need to soak this in, eh? Like, this is something you real had to soak in, bro. Like, you're not gonna understand it just by looking at it. Um, front. All right, so Zachary, how much planes do I have there? Tell me, how much planes do I have?
2.
I have two, right? Great. Now,
Yeah.
Zachary, it's all way to imagine. I want you to imagine that this plane over here, this blue plane, is separating two mediums. So over here, wait, what medium you want to have over here?
That could be the A.
Okay, that could be air, right? So
Yeah.
this could be air. Wait, let me just check something real quick. All right, so that's air, and we want this medium to be.
Water, so.
All right, that's water. I'm gonna find out a good diagram. Give me a second. See if I can find out a good diagram. Okay. Let me just fix this diagram up a bit. Now, I could always just find a diagram online, but I feel like it's in your interest if you see me draw it myself. Okay, so Zachary, I have two planes intersecting each other. So can you see with your own eyes? I have a plane over here, a 2D shape, and I have another plane over here, both of them intersecting. See now?
Yes, sir.
Okay, I'm telling you that over here is air, and I'm telling you that over here is water. That is what I'm telling you, right?
Yes, sir.
Okay, good. And this boundary over here, this think about it. Imagine you're in the sea, right? And you have the ocean. And and you just have like a boundary of water. Like, oh, I just talking about the top of the water, the top of the water. Isn't it
Yes,
like a
sir.
line separating that from the air?
Yes, sir.
Yeah, that is what this line represents. And the proper name for this line is the boundary line, right? That's really the boundary plane. Boundary plane. Now I'm going to draw an incident ray over here. Now the incident ray is going to be incoming. Some of you seeing that? So this is the incident ray.
Yes, sir.
Can you tell me quickly what the green line represents in this whole thing?
You know, also
Right, the green line represents the normal. Great. And this is the angular what?
angular incidence.
Right. Now, what is this talk about the line on the same plane? Can you see that red plane over there?
Yes, sir.
I think you've seen it first. I think you see what's gonna happen, right? I think you could see what's gonna happen.
Yes, so that's what I mean by they lie on the same plane.
Right. That is what they mean. Because
Well, yes, that makes sense.
here it is, right? The you see this over here? Because the whole time we were thinking about it in two-dimensional space, but do we live in a two-dimensional world?
No, so
No, we don't live in a two-dimensional world. So this is actually what's happening in real life. So you could think of this as the surface of water, and this is air. So this is called the what? What kind of plane is this? This is the what plane?
boundary plane.
This is the boundary plane. Good luck drawing this. That is the boundary plane. And the red thing over there, what is that? What is that? Let me see if I can figure it out. What do you think that red plane is called? The red plane. Think of it, Zachary. Think about it.
That's for sure.
All right, no problem. Just think in three-dimensional. Think in three dimensions. So like what this diagram looking by. I find it was better the other way. Hey, we'll work with that, right? We got how to work with that. Yeah. So Zachary, look, I want you to look at the two-dimensional drawing. So look at this one, Zachary. Ain't you okay with the boundary plane?
Yes, so it would be the normal plane.
Exactly.
Right.
Right? And well, the proper way to say it is the plane of incidence. This is the plane of incidence.
Right. So
And this will be the plane of okay,
plane of
incidence, plane of
refraction.
refraction. Yeah. Plane of incidence. To try to understand it now, it says the angle of incidence and the angle of refraction lie on opposite sides at the normal, but all lie on the same plane. Let's make sense of that now, Zachary. So you have a two-dimensional plane over here. You have your normal over here, right? The incident ray lies on the plane of incidence, and the refracted ray lies on the what?
Plane of reflection.
Right. And both of them lie on what? The same side or the opposite side?
Opposite sides.
So now you actually understand it.
Yes, sir.
Nice. And this is just simply refracted ray. And this is the angular refraction. Shana, let me know if you understand that.
Yes, sir.
I mean, it's kind of hard to visualize per se, but I want you to think in three-dimensional
Hands-on.
space. Three-dimensional space. This is actually a flat plane, and the incident ray is over here, and the refracted ray is both on the same plane. That's really what's happening. So I'll give you all some time to copy this down, and I am coming back. So when you're done copying on everything, I'll go over everything and we'll do a question. We'll do a past paper question. Did everybody get a chance to copy down the first part? Let me know, guys.
Yes, sir.
How about the rest of you all? Did you all get a chance to copy down everything here? Let me know, guys. Drew, Shayna, Karina, Adil, Zachary, uh, Vani, you here? Vani, Nikolai, Jiran. Let me know, guys.
Yes, sir.
Okay, I'm gonna scroll down now. These are the formulas you need to know. So you need to know Ni sin I is equal to Nr sin R, and that is really the general one. And you need to know Nr is equal to sin I over sin R. And that is specifically when you're going from A to another medium. Guys, I'm gonna hear now.
Yes, sir.
Okay, I want a little to be honest with you. I feel like I don't understand in refraction.
Yes, sir.
I hear Shayna say, yeah. If you don't understand, that's okay, you know. Just tell me. I will go over it infinite amount of times if that's what it could take for you to understand. It's fine. But just tell me that you're confused. So I will know I need to do more work. Adil, you confused? Adil?
Not really. Yeah.
Not really? Okay. Jadon, be real honest with me, like 100% transparent. No refraction. Be 100% transparent.
I'll search it up.
Okay. Okay, cool. Vani, let me know if you are confused by anything.
I understand it, but the part where I missed, if you could go through it after,
Don't
that
worry,
would
I'm
help.
going through all of this. I'm gonna go over all of this. Don't worry. Gonna go over every single thing. It's fine. All right, Ambika, I know you know well, but indicate some way that you're following or you're not following. So I could
I understand.
oh my God, I hear a voice. Hey. You know something that bad, you know, like you know something that bad. You sound like you still have life in you. That's good. That's good. Happy to hear you understand. All right, Zachary, we good?
Yes, sir.
All right. Karina, Biokills, Physics Live. Yeah. Karina, let me know if you're okay.
Yes, sir.
Don't worry, Karina, I'm gonna go over this entire thing just now. Once I have all the notes copied down. I'll have your notes copied down.
Yeah, I could, but that's you know.
Hmm. I didn't say that, but I don't trust it. I don't trust it. I don't trust it. Yeah. Because I've been in all issues and I'll always be like, you think you understand something, you really don't understand it. And you feel ashamed to ask the teacher to go it over again. I know.
Also, mock starting next week.
Okay, okay, noted. Noted. All right. So, okay, I just copy down.
Yes, sir.
All right, bet. Copy this down now. Why'd have a random F over here, bro? What? This is supposed to be refracted ray. Zachary, I have a question to ask you, right? I have a question. I have a question, right?
Yes, sir.
So, Zachary, if you go in from a less dense to a more dense medium, where does your refracted ray tend to bend towards?
It's been towards more towards the normal.
All right. So stay with me, right? If I were to say increase this angle over here, then the refracted ray will what?
It will go more towards like the normal. Yeah, it will be like that, sir.
All right. And what if I do the opposite now? What if I up on there?
It will go further from the normal.
Exactly. Now there is a point where um it actually looks like this. And that's called the critical angle. And when you pass the critical angle, um actually that can happen in this scenario. In this scenario, that cannot happen. But when we look at from water to air, you'll see something called total internal reflection. And so basically what I'm saying, Zachary, is it have a point where the incident ray is going to cause this to hit the boundary line. You could possibly imagine that, right? Like if I adjust the incident ray, at some point the refracted ray will be in line with the boundary line. Make sense? Like at some point.
Yes, sir.
And at that point, you would call that the critical angle. And if you go past that, if you take if you take an incident ray and you move it anymore, it's going to reflect. So you'll see that in the next class. I thought you're gonna look at that in this class, but
All
yeah.
right.
Well, after this topic, we need to look at lenses, and that is it for waves and optics. We can move on to electrical physics. Best part. Best part. I wonder why I say that. I don't know. All right. Do you all have everything here copied down?
Almost, almost.
Almost. All right. Adil, I don't know how much you have copied down.
Yes, yeah, on less dense medium.
Okay. Okay, guys. So, do we have everything copied on? Yes, no, maybe, potentially.
Yes, sir.
What about the rest of you guys? I feel like I was only here from Shayna and Zachary. Drew, Adil, Karina,
Yes,
Jadon.
I
Yes, sir.
Alright, let me
Yes,
move
sir.
on. Let me move on, right? This is rapid fire. Imagine we playing Kahoot, right? Imagine we playing Kahoot. What is refraction? Go. What is refraction? Anybody? This is Kahoot. I give out only points, right? Like, let me see who getting the
Um,
most points. Wait,
depending on who you find it and another video.
okay. I got remember I don't want their names. Drew, Shayna, Karina. You see, this is why I can't have too much people in these classes and otherwise I got dead. Because I can't leave anybody out. Imagine if I had like 50 people in this class. That'd be crazy. One day though, one day. But I don't know how I'm gonna manage that. That would be insane. Vani, Nikolai. I'll make her leaving out because I know you're not feeling well. And I can't really talk much. Alright. That first point will I go to Shayna. Shayna, I wanna just repeat what refraction is to everybody. Loud. Listen
Depending
listen to Miss Sheena Thomas. Listen.
depending on who is on the and another medium.
All right, Jaden. It is run the same speed in water and air?
No,
No, so you think light go and travel the same speed in water and air?
no.
No. So, Jaden, tell me, what is one law of refraction? What is one law of refraction? What is a law of refraction? Presume you're not copy down the laws of refraction.
I have the Snell's law.
Yes, Snell's law is one. Could you tell me what Snell's law is?
The the ratio of the sine of the angle of incident to the sine of the angle of reflection.
I feel like you're Googling that. I feel like you're Googling that. I have a
I,
strong feeling.
I have it here.
A strong feeling. Because that sounds like a Google definition. I know because I didn't go through anything so like I mean it's simple, but it sounds complicated. I doesn't try to make anything sound too complicated. I know that's hearing that from online. Could see it. All right. Um, Jidan, one of the laws of refraction is that light bends when it goes from one medium to another medium because the speed of light is different depending on the medium it is in. So like depending where you have light traveling through, it'll be faster, it'll be slower. And that causes the light to bend. And this relationship is quantified via Snell's law, which is Ni sin I is equal to Ni sin R. So when you have light going from one medium to another medium, it bends because light travels at different speeds in different mediums. And that's Snell's law. Ni sin I is equal to Nr sin R. So I can't really give you a point there, right?
Mm.
Um, Zachary, give me a law of refraction.
The normal is always perpendicular to the boundary line.
Right, the normal is always perpendicular to the boundary line. If you are confused about that, this is the normal here, and this is the boundary line. Okay, so I'll give you a point, Zachary. Somebody else, Vani. What would I call this ray over here?
The incident
What would I call this?
the angle of incident.
Okay, you take 2 points, take 2 points. Badness. All right, Adil. Adil, what would I call this? The incident ray or the refracted ray?
The refracted ray.
Right. Let me just say we go in from air to water, right? Air to water. Air to water. You tell me, Adil, which one is denser, air or water?
Water.
Okay, so if it's going from a less dense to a more dense, where does it want to bend towards?
If it went from what?
Less dense to more dense. Where will it bend towards?
It would bend towards the normal.
It bend towards the normal. So should that line be over there? Should it be over here? Or should it be over here? One, two, or three? What do you think?
I feel it's true.
I feel it's two because it would bend closer towards the normal, right?
Yeah.
Excellent. Take 2 points. All right. Karina, what is the name of this line over here? What's the name of this line over here? This line.
Boundary.
I take our point. Take our point. All right. Karina, what is the law of refraction? What is the third law of refraction? What is the third law of refraction? Third law. It has to do with this. Tell me, Karina. Third law.
The incident is on the opposite side as the refraction.
And they lie on the
And they lie on the normal.
Now they lie on the same plane. I said
Oh,
earlier that a normal is a plane, but really, the normal
so
is not a plane. The normal is not a plane. The normal is just a line
normal, not
perpendicular to the boundary line. So
oh,
I can give you a half mark, but this is the proper thing it's supposed to say. It's supposed to say the angle of incidence and the angle of refraction lie on opposite sides of the normal, but all lie on the same plane. I'm not sure if you said it like that, but you had to mention that they lie on opposite sides of the normal. You can't make it sound like the normal is a plane. The normal isn't a plane. The normal is just a line. The normal is just a line. So this is a line over here for the normal. The incident ray on this side and the refracted ray on this side. So they're on opposite sides. See now, right? This is normal. The incident ray on this side. This is the left. And the refracted ray on this side. This is right. So they're on different sides. So you had to mention that the angle is gonna be on opposite sides of the normal. But they're gonna lie on the same plane.
so I have to mention the plane.
Yeah, you have to mention the plane.
Oh, okay.
Gear one, or gear scratch out the two. All right. Can somebody tell me? Okay, Drew, can you tell me the general formula for Snell's law? General formula for Snell's law.
Um, Ni sin I is equal to Nr sin R.
What is Ni standing for? What is Ni? Ni is the what?
The refractive index of the incident ray medium.
Okay, let me try to run through that, right? So, um, Drew, depending on your scenario, you might be going from one medium to another medium, but we don't know for sure. So, Ni is just a refractive index of wherever the incident ray is. So let's just say the incident ray is in water, then an Ni would really be the refractive index of water. So Drew, let me just say it was in glass, right? If it was in glass, the incident ray would be in glass. So the refractive index would be for glass. You understand?
Mm-hmm.
Right, so refractive index of is really just a refractive index of wherever the incident ray is. So I'm just gonna write for now refractive index of incident ray. That's not the proper way to say it, but wherever the incident ray is, the refractive index will take suit. All right. Drew, tell me what R stands for. What does R stand for?
The angle of refraction.
Right? Correct. What is Let's write I over here, boy. Yeah. What does I stand for?
The angle of incidence.
Cool. What does NR stand for?
The refractive index of the medium of the refracted ray.
Perfect. Perfect. What is the other formula? You take 2 points for that. Nice. Score double the points now. What's the other formula you could use strictly talking about air to another medium? If we go in from air to something else, what's the formula we always use?
Nr is equal to sin I over sin R.
And okay, what would NR be? NR is really the what?
The refractive index of the other medium, the
Right,
refracted ray in. What about the
right.
yeah,
And could you just remind me what the refractive index of A is?
one?
Does everybody agree that the refractive index of A is 1? Yes or no, guys? Talk to me. Refractive
Yes, sir.
index of
Yes,
A
sir.
is 1. All right, cool. Great. Take 4 points. So anytime you're going from A to another medium, this is the formula you're going to use. I mean, it's fine to use the long formula, sure, but you have more working to do and you have to make things the subject of the formula. Anytime you're going from A to a medium, which is usually the case, just use this formula. And most of the time you wouldn't even see NR, you could just see N is equal to sin I over sin R. But I put the NR so you don't get confused. All right. What else I could ask, boy? I didn't ask Jaden. Jaden, you didn't get a point. All right, Jaden. Well, question I could have here, boy. Let me think. Okay, Jaden, we essentially went through everything. Jaden, just to pick you up on some specific things, just to make sure you understand, Jaden. That dash line over there, what's the name of that dash line? Jaden, what's the name of that dash line? Do you know? Jaden?
Hello, yeah, no?
Yeah, that dash line over there. Do you know what you call that?
Yeah,
If you don't know, tell me up front. No waste your
I'm
time.
not sure.
Not sure? All right. So we call this the normal.
Mm,
Call that the normal. I want you to understand that this is okay. Maybe this might be air. That entire and everything over here could be air. You could be in air over here. So you could be in air over here, and you could be in water over here. So if that is the case, what is this line doing?
separating it.
Right. What do you call a line that separates two things? So that's what B.
Boundary.
Right. So you call this the boundary line. Don't mind the scrappy handwriting. We're just trying to understand the concept. Um, if I am coming in, right? What ray would I call that? The incident ray or the refracted ray?
Incident rate.
Right. Think of it like this. Incoming. Incident.
Mm-hmm.
Incident ray. Now, how am I going to measure the incident ray? Am I going to measure it with reference to the boundary line? Or am I going to measure it with reference to the normal?
Reference to the bomb.
Yeah, that's why the normal there, right? That's the whole purpose of the normal. The normal is
Yeah.
there so we could have a reference point to measure the angle. Cool.
Mm-hmm.
So that over there is going to be I, which is the angle of incidence. So after we go through this, we could actually do a password question. We're in a good position. At least we understand how it is actually work. So Jadon, what would I call this line here?
The refracted line.
Right, the refracted ray, right?
Great.
Now, since I'm going from air to water, which one is more dense, air or water?
Water.
Right. If you're going from a less dense to a more dense, it bends towards the what?
It bends towards the what?
Yeah, what would it bend towards? Would it bend towards the boundary line or the normal?
The normal.
Right, you're gonna bend towards the normal. So in this instance, I is always going to be more than R because they're gonna bend towards the normal now.
Mm-hmm.
All right, cool. Yeah, what do we do a question now? That was it for the recap. I feel like Drew won, but to be fair, I didn't ask everybody same amount of questions, so that kind of unfair. But Drew, it seems like you understand everything. Would you say you feel like you understand everything?
Yeah.
I bet. Let's look at the 2026 question now. Took order. Unfavorited. Bruh. Oh, they don't show folders. That's tough. That's tough. Favorites. Oh my God. Oh my days. This is not a fun time. Why would I do that? The amount of notes I have here is ridiculous. Okay, here it is. Past papers. Okay, there we go now. There we go. So who wants to do the question, mama? Do I have any volunteers? I promise it's simple, you know. Like I promise, I swear to God it's simple. Physics in general is simple, I promise. I promise, guys. Promise. Anybody, any volunteers? You know what? I'm gonna volunteer, Sheena. Sheena,
Yes, sir.
I doubt you're gonna let me know. Alright, so read part C for me.
A student investigates reflection of light when it travels from glass to air. Figure 7 shows the arrangement of the apparatus for the investigation.
Ah, you see that? Can we use the air to medium formula?
No, sir.
Nah. Maybe we will see, right? But just from looking at it, I don't think so. Because in this case, you're going from glass to air. So if this is the case, the angle of incidence would not be 1. If you see what I mean shortly. So guys, when we look at this, where is the incident ray coming from? Like where is it entering? Like where is the ray incoming from? Where's it incoming? For they had to say. People in class. Which one looks like the incident ray?
Um,
1 or 2?
the angle G is the incident angle, so coming from there, from the Reeboks.
What about the rest of you all? Vani, Zachary, Adil. Where does the light look like it's coming from? Does it look like it's coming from here? Or does it look like it's coming in here?
Coming in from the box.
It coming in from the ray box. I mean, our ray boxes literally produce light, guys. That's what our ray boxes do. So, if this is the case, then we know that this is the what? This is the incident ray. And this would be the what? Somebody tell me, Shina. This is the what?
Oh, sorry, that's good. Refracted ray. Sorry.
And this would be G is literally I, and A is literally R. Say with me, right?
Yes, sir.
The student measures the angle A and angle G in glass and records the results as shown in table 2. So they're telling us that angle A is 48 degrees. I don't see why they could not just put it for us, in the diagram. 48 degrees here, and angle G is 27.5. Shayna, let's use our wonderful inductive abilities to see if this makes sense. So Shayna, in this instance, we're going from a more dense to a less dense. What are we doing?
We're going from more than distance.
We're going from a more dense to a less dense. If you're going from more to less, what do you bend? What happens?
The line will be going towards more towards the boundary.
Nah. If you're going from a more to a less, it would bend away. It would bend away from the normal.
Well,
Like,
I said more towards the boundary.
okay, okay. Well, yeah. So does that make sense? Because watch, it bending away. So you see the angle get bigger?
Mhm.
Okay, good. Using the data in table to calculate the refractive index of glass. So we want to find the refractive index of glass. Somebody in class, can you tell me if that would correspond to Ni or NR? Which one do you think is going to correspond to the refractive index of glass? NI or NR? Somebody tell me.
NRC.
Be careful, you know. Be real careful here. So Zachary said,
NI.
And I.
okay, wait, guys. We want to find the refractive index of what? I promise it's real simple, but we want to find it of.
Of glass.
Zachary, glass, right? Where is the glass? Where is the glass? Is the glass over here? Or is the
That's it.
glass?
Yes, it will be NI.
It will be Ni because that remember, Drew, I was saying that the refractive index. Okay, I was saying that Ni was just simply the refractive index of wherever the incident ray is. Remember, I was telling you that? Yes or no, Drew?
Yes, sir.
Right. So, Drew, when we trying to figure out the refractive index of glass, where is the glass? Isn't it here?
Mm-hmm.
Right. Zachary, I lose our mark, boy. I had to think about it.
Yes.
Okay. So we want to figure out the refractive index of glass. So we need to form our equation. What is the general formula? What is the general formula, guys?
NI sin R equals NR by sin R.
Okay. Let's put in everything that we know so far. Do we know what the refractive index for the incident ray is? People in class, Vani, tell me if you're lost. Like if you're lost, yeah, it's someone now. Yeah, it's someone now.
No, I understand so far.
Right, so Vani, we're trying to figure out the refractive index of what here? According to the question, we want to figure out the refractive index of what?
Glass.
Now the glass is where? The glass is by the incident ray or the refracted ray?
Refractive.
Look at it carefully.
Oh, then the incident, sorry.
Right, because the refracted ray is really air. Where's the incident ray? The incident ray is in glass or air? Come on, Bika. The incident ray is really in where?
In glass?
It really in the glass, right? It really in the glass. When Vani, you see now, right? It literally in the glass.
Yeah.
So we're going to use Ni sin I is equal to Nr sin R. Now we want to find the refractive index of the glass. Now, Vani, which one of these variables here corresponds to the refractive index for glass? Is it Ni or is it Nr?
NR?
Again, I wouldn't have anything to do with R. Let me explain why. We want to figure out the refractive index of what?
Glass.
Right. Look at the refracted ray and the angular refraction. Where's that? Where are they? Where are they? Tell me, Vani, where are they?
They are in the air.
Right. So NR would actually be the refractive index of,
Air.
yeah, because it's in the air. Now, the ray box is entering glass. So the refractive index for the incident ray is going to be equal to the refractive index of,
The glass.
right. So we are actually trying to figure out NI or NR. Tell me, Vani, we're actually trying to figure out NI or NR.
NI.
Yeah, we're actually trying to figure out NI. So, here what? Maybe we could make that the subject of the formula. If I wanted to make NI the subject of the formula, what I need to do on both sides?
Divide both by sin I.
Right. So NI is going to give me NR sine R all over.
Sin I.
Now, guys, I want everybody to tell me, do we know what the refractive index for the refracted ray is? What is it? Could anybody tell me
One.
the refractive index for the refracted ray and explain why? Why you say is 1? Where's the refracted ray? Tell me, guys, where is the refracted ray? It's in what?
Yeah.
A. So that's gonna have a refractive index of 1. Fanny, you with me? Shina? Shina, let me know. Shina?
Yes, sir.
So I'm gonna replace NR with 1. What am I going to put for my angle of refraction? Tell me, Fanny, what am I gonna put for my angle of
I'm sorry.
refraction? That's okay. Fanny, what is my angle of refraction?
40 degrees.
48 degrees. Then I'm gonna put sine I. What is my angle of incidence?
27.5.
Plug that into your calculator and let me know what you're getting. And anybody answer? Anybody?
Yes, sir.
Okay. Somebody other than
Um,
Shina. Nothing personal.
okay.
Anybody want to tell me what I get?
1.16. No, 1.61.
1.61. That is correct. And that's your answer. Guys, guys, the hardest part about this question was trying to figure out what. Okay, I really wouldn't say the question was hard enough. I just think all I had to sit down and understand what the question asking and trying to figure out what NI and NR is. Vani, were you able to get the 1.61 or no? Be honest.
Yeah, I did. It was just I was giving a little trouble with my calculator.
All right. Um, Ambika, Zachary, Adil, Jiran, Drew,
Yes, I get it
Nikolai.
1.61.
Okay. Now, if I were to go online and look up the refractive index of glass, where do you think it will be?
1.61.
It's actually have a range, you know. Are all glass built the same? That's the question. The answer is no. Watch. You see? The refractive index of glass is typically between 1.4 to 1.7. Yeah. So like crown glass is like typically between 1.5 to 1.6. Flint glass is 1.6 to 1.7. So the type of glass we might have is flint glass. Yeah. Is everybody okay with this question?
Yes.
I I I
Yes.
I, I don't feel satisfied, you know. I feel like all it real confused and like some of them just like not saying anything. I need to do this question one more time. I just really don't feel content. I feel like all it just saying yes, but I don't fully understand it. So trust issues run deep. Really deep. Adele, you there? Actually, no, let me call Jiran. Jiran is the man for this. Jiran is the man for this. Jiran, you there?
Yes, sir.
Jiran, you thought it was gonna escape. No, no. I'm looking
Nah.
at you, you know. I'm looking at you. Jiran, what is the general formula? What is the general formula for Snell's law?
Six and British.
Wait, is the general formula? I hope you copy down the notes because everything you
And
need.
I sin I plus the NR sin R sin R.
Right. Ni sin I equal to nr sin r.
Beautiful.
Okay, here what? The first thing we need to do when we look at this is figure out what is the incident ray and what is the refracted ray? And where are they? So the incident ray is what is where the light source is coming from. Where is the light source coming from, Jadon? Is it coming from, well, you tell me, is it in the air or
The ray
is it in the glass?
box,
Is it in
the
the ray box?
glass.
So this is going to produce an incident ray. That is going to produce our incident ray. Cool. If that is the incident ray, Jadon, what would G be?
The the refracted ray.
No. G is a measure of a what?
Oh, G. Um,
G is a what? That's what A. What is G? G is a measure of a what?
I don't know.
All right. It is an angle. G is an angle. See, now like an angle. So, okay, I don't want to confuse you. An angle is just you could just think of it like the distance between two lines at a common point.
Mhm.
This is an angle. See that?
Yeah,
And it's the angle formed by the incident ray. So I would hence say the angle of,
I.
now the angle of incidence, because it's formed by the incident ray. So you could think of G as really being I. Okay, so we figured out that this is the incident ray. What would this be?
Well, the refracted ray.
Okay, and what is A going to be?
Um, R.
Yes, because that is just the angular what? As the angular what?
Refraction.
Exactly. Yeah, ready. Angular refraction. So l- let me I do mark this working from scratch here because you see, like I knew Somalia was a bit uncertain about this. I knew I could have smell it in the air, no little confusion. Could have smell it. That's fine. We making sure we understand anything. So, Jalen, we successfully recognize what the angular refraction is, the angular incidence, the incident ray, the refracted ray. Right. Now, Jalen, where is the refracted ray? In what medium is it in? Where is the refracted ray? Tell me, Jalen,
The
where is it?
in the glass.
Okay, so this is the boundary line, right? Wait have over here? What's this? Everything below the boundary line there is what?
The glass.
Right. So where's the refracted ray? Is the refracted ray in the glass?
Yeah. That is it not?
Nah. You see in the refracted ray anywhere over here? Check it out there. I don't being mean or anything or like asking a
No, no,
sarcastic.
no, 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 no.
You see
Uh-uh.
you see in the refracted ray. Okay, so everywhere over here, this is just glass. That's glass.
Mhm.
What are you seeing in the glass? Tell me, Jada, what are you seeing in the glass? What is entering the glass?
The the ray,
The incident ray that comes from the
incident
ray
ray.
box.
Mhm.
Right. So the incident ray is in the glass because it's what? It's in the glass. All of this here is glass.
Right.
What is in air? Everything here is air. What is in the air?
Okay, I kind of lost.
Okay,
It's the way.
all right. So this is the boundary line, and it separates two different mediums. It separates two different mediums. Of example you could think about is like, in the sea, you would have water over here, and you'd have a line, and then you would have air over here. Yeah?
Yeah.
Okay. You sure you understand this, right?
Mm-hmm.
So like in the sea,
Yes.
you have water. This like could be the sea level. This is water over here. And above the water you have what?
Yeah.
And below the water you have, yeah, water.
Below the water.
Yeah, water. More water. Right? The line that separates the two of them is called the boundary line. So over here, Jadon, you have a line here, and it separates what two things? What two things does it
The
separate?
air and the glass.
Right. So everything below the boundary line is what?
Glass.
Right. All of this is glass. And what am I shining into the glass?
The ray. The incident ray.
Right, the incident ray. So the incident ray is in the.
Glass.
Yeah, because think
No.
about it, Jadon, what really happening over here, right? Your ray box, you can think of it like a laser. We literally doing, Jadon, you're taking a laser and you're shining it into glass.
Yeah.
So like the incident ray is actually in what? It's in what?
You're shining it into the glass. So it's going to be in the air. That's what you're trying to say.
No, no, it's in the glass. In the
It's
glass. Like
in the
for that
glass.
for that
Okay.
portion there, you're taking the light and
Mhm.
you're putting it in the glass. So like you're shining the light into the glass. So it's in the glass for this region.
Yeah.
Now when it escapes the glass, where does it go to?
The air.
Right. So what is in the air? The incident ray or the refracted ray?
Refracted ray.
Right. That's the whole point I was talking about. So the incident ray is in the where?
In the glass.
And the refracted ray is in the.
Air.
That's it. You understand that?
Yes.
Good. So Ni Ni stands for the refractive index for the incident ray. So Jiran, Ni is really just the refractive index of what? Where is the incident ray again?
In the glass.
Right. So Ni is really the refractive index of what?
The refracted index of the ray.
No, okay, so refractive index tells you how you can think of it like how dense a material is and how it would bend light. So what medium or material is the incident ray in? Where is it in? It's in what?
The glass.
Right. So Ni really is just the refractive index of
Glass.
yes. Because the incident ray is right now it's in the glass. So it would depend on the refractive index of the glass. So Ni, in this case, Ni is really the refractive index of glass. Okay. And what do you think Nr means? In this instance, what do
The,
you think Nr represents?
the refracted index of the air.
Yep, refractive index of the air. Now, which one of them we know? Which one of them we know for certain?
The glass.
Nah. We know we know with 100% certainty that the refractive index for air is always what? Somebody tell me in class. What's the refractive index of air always?
1.
Is 1. Now, Jidan, why? Jidan, refractive index is telling us how dense a medium is. It's also going to tell
Mm.
us the degree by which something is going to bend. So I'm asking a question. Where do we live? Do we live in land on water.
Land.
So how do we perceive light? We see light through what? The light passes through what? When we see light, light is passing through what? Central
Air.
air. Exactly, air. So Jaden, we are going to use air as a reference. So what I mean by that is we see in light through air. So for us, that is not gonna we're not gonna perceive that as being refracted. We're gonna perceive that as being normal now. So that's why we call it one. If you multiply something by one, what you get? Like okay, if I multiply five,
The number you multiply.
exactly. So it makes sense, Jaden, because if we perceive light through air, then that'll be the reference point. So we'll just call it one because that's how we perceive light. Light for us, we perceive it through air, so it doesn't change. That's why we call it one. Understand?
Yeah.
If it's not one, that means it's gonna bend somehow, comparatively to air. But if since we see light in air, we just call the refractive index one because it doesn't change. It doesn't change anything, it doesn't bend light. We see it in air. And in the question they would have say, take the refractive index of air to be one, even if you forgot it. Hope after that you don't forget it, right? So the refractive index of air is always 1. So NR in this case is going to be equal to,
1.
right. And in the question, we want to find the refractive index of,
Glass.
so what variable here represents the refractive index of glass?
Sin I.
No,
No, Ni, sorry.
Ni, right? So we need to make Ni the subject of the formula. It's going to be Ni sin I is equal to Nr sin R. What would I need to do on both sides to make Ni the subject of the formula? What would I need to do to cancel this off?
Um, yeah, divided by sin I. Sides.
Correct. You divide it by sin I because right now Ni is being multiplied by sin I. So you do the opposite to cancel it off. So you divide instead. And when I divide both sides by sin I, what am I going to get?
Ni is equal to Nr sin R
Right.
over sin I.
Could you tell me what the refractive index of R is? So like R. NR. What's NR?
1.
1. So it's going to be 1 multiplied by sin R. Now, in the question itself, they told us that the angle A in the air, A is actually 48 degrees, and they told us that G is actually 27.5 degrees. So, if that is the case, Jaden, I could replace R with what?
48 degrees.
And I could replace I with,
27.5 degrees.
great. So in the calculator, you're going to put sine 48 divided by sine 27.5.
1.60.
1.60,
61.
1.61. Yeah.
Yeah, because I see that.
And that's your answer? That's it? That's it.
Um,
Yeah. So you needed to identify what was the incident ray, the angle of incidence. You needed to figure out where that was. So the angle of incidence and the incident ray is in glass. You need to figure out where the angular refraction and the refracted ray is going to be. We figured out that's in air. So we're going to use Ni sin I is equal to Nr sin R. We were able to see that the refractive index of the incident ray. The incident ray is in glass. So Ni is really the refractive index of glass. Nr, that is the refractive index for the refracted ray. The refracted ray is really in air. So that's really the refractive index of air. And that is 1. Now in the question, they want us to figure out the refractive index of glass, which is Ni. So we divided by both sides by sin I to make Ni the subject of the formula. Then we just plug in everything and we go 1.61. Is everybody in class okay with this question? Yes or no?
Yes, sir.
Okay, good.
Yes, sir.
Yes, sir.
Now, guys, let's see what would happen if you use the formula that your teacher gonna teach you in school. This is the way it would look like. N is equal to sin I over sin R. So Shina, when you use this formula, right? It's saying sine of the angular incidence. What's the angular incidence here?
27.5.
What's the angular refraction?
48.
Yeah, when you plug that into your calculator, long story short, you're not gonna get 1.61. You will not. You have to be very careful when you're using this formula. This formula only works strictly when you're going from what?
From A to another medium.
Exactly. Air to another medium. Were we going from air to another medium here?
No, sir.
No, we were not. We were not. Cool. You might learn some other formulas, but I've learned over the years that this is the easiest approach. Especially if you're good at maths and you can easily make things the subject of the formula. I recommend this. There's also the one you might also see some people writing NR is equal to sin R over sin I. You're also gonna see people writing that. But truth be told, I find like this looks simpler. But I wanna make sure I wanna see if Alia agree though. Be fully objective. What looks easier to work with? Ni over nr is equal to sin R over sin I, or this. If you all had to say which one looks simpler to work with? One or two?
Too soon.
So 1.
All right, no problem. Everybody is different, right? Some people might pick two, some people might pick one. It's the same formula, right? But I personally would go with one. So that is it for class today. So now we should be able to understand refraction as well as Snell's law. In the next class, we're going to look at critical angle, total internal reflection. We're also going to look at we're going to look at reflection, of course. And that'll be it for this particular topic. And we'll start a bunch of past paper questions. Then in the next class, lenses. I don't want to rush this topic, as this is one of the harder topics in physics. We have ample time. Only in Form 4. Right? Only in Form 4. We more than half the way down with the syllabus. So we will finish the syllabus. Relax. We will, I promise. Shina, so let's unmute.
Oh, I was gonna say if I could access them after class.
Sure, no problem. You can ask me now if you want. Or is it like personal? Shina?
Oh, yeah. Hi, sir.
Yeah, is it like a personal question? You could ask it like in front of everybody.
Not necessarily.
It's not a personal question, or I'm trying to understand what you're saying. So you're saying that you want to talk to me, like in private or like in front of everybody?
I guess it doesn't matter.
Say that again?
I guess it doesn't matter.
I don't understand what you're saying. Um, no or after class?
So after.
Okay,
After.
no problem, no problem. So yeah, guys, are we okay with recognizing the incident ray, the refracted ray? Yeah, we okay with that?
Yes, sir.
Yes, sir.
Okay, cool.
Yes.
Cool. So it was a good class. Um, Again, this is one of the harder topics, so I understand that there were some points where people were confused. I hope the confusion is not there anymore. I really hope so. Um, Please do practice. I don't wait to just forget. So you know, I should probably find a possible question to give all the for homework. That makes the most sense. Let me get a question quickly. Well, I see this question is one of the hardest questions. I wouldn't give all it to do this, but we definitely have to do it. Let me just put the questions here because we have to cover this question in next class. Ooh, this is a nice question, man. This is a nice question. I like this question. I'll go do this. Lovely. A beautiful question. I feel like we spending real time on like this topic. Like, real taking time on this topic, which is good. But like I said, it's one of the hardest topics in physics. C-Sec physics. Nice. Nice. So just for your record, I did give you all homework. This is the homework. Yeah, this is the homework. All right, so yeah. Just stop the recording.